Welcome student to the lecture of Power System 1. Today we will begin with third unit, that is mechanical design of overhead lines. So in previous lecture we saw, in previous two unit we saw about various factors which are related with the power system, such as load flow factor, diversity factor, and we also saw about various tariffs, and we also solved the numericals related to that tariff. In second unit, we saw about the various equipment which are going to be used in power system, like circuit breaker, relays, bus bars, and we also saw about cables and different conditions of cables and dielectric stresses in cables. So today we will begin with the third unit, that is mechanical design of overhead line. The content of these topics are mechanical design of overhead lines. We will see the various types of line supports, various types of conductor. We will see the sag analysis, and we will also solve the numericals on sag analysis. And in second part, we will do with the line conductors, various types of line conductor, and we will do the analysis of string type, suspension type of line conductor, and we will solve the numerical based on it. So the third unit, that is mechanical design of overhead line. Mechanical design, as we know that the electricity is distributed by the means of underground cables and overhead lines. But the main drawback of using a cable for the distribution is, firstly, the cost of installation of underground cables is very high, and secondly, as we are going to transmit higher voltages by using cables, the proper insulation has to be provided, and which is going to be very costly. So to overcome this disadvantages of cables, we are going to study the various mechanical designs of the transmission lines, which includes cables, which includes conductor, second supports, third is insulators, fourth is cross arms, and fifth means there are some miscellaneous items. So firstly we will begin with the conductors. So what is the conductors? The conductor, we can say it just like a heart of an transmission line. The main function of the conductor is to transmit the voltages from sending end to receiving end station, right? The second important part of a overhead component of transmission line is supports. The supports, main function of support is to support the conductor, so it can take the various stresses. It can it can be able to bear the various stresses. Third is the insulator. The main function of the insulator is to, we cannot directly connect the conductor to the supports, because to insulate that conductor from the support we require the insulators. So insulator is to support the, it is attached to the supports and it is used to insulate the conductor and supports. The fourth one is cross arms. The main function of the cross arm is to support the insulators, and there are various miscellaneous items like lightning arrestor, anti-climbing wires. These are the various. The firstly, we saw the first main component of overhead line is conductors. So as we have already discussed, the conductor is the heart of the transmission line, because whatever the voltage we are going to send from sending end, that is going to be received on the receiving end. So there should not be any losses of the voltage in between that. For that purpose we require the conductor. So what are the basic or the main properties of the conductor. Firstly, it should have a high electrical conductivity. Means electrical conductivity means there should not be any losses in the transmission conductor. Secondly, it should have high tensile strength. Means because as we know that overhead conductor, it will be subjected to various physical condition like wind, ice, and to overcome this, the conductor should able to bear the mechanical stress which is going to be applied on it. Thirdly, the conductor should be low in cost, because this is the main parameters while considering the conductor. And fourth is it should be light in weight, means it should have less specific weight. It should not be more heavy, because if it is more heavy, then we will have to design the structure which can bear the conductor heavy conductor weight. So while choosing the conductor, we should choose the conductor which are light in weight and which is having high conductivity, high tensile strength. So we will see one by one, see what are the different conductor material which are used in transmission line. The first, the generalized commonly used material are copper. Second is aluminum. Third is steel coated aluminum. Fourth is galvanized steel. Fourth is cadmium. So depending upon the requirement and mechanical properties, we are going to use that conductors. And mainly the conductor are preferably the standard conductors, means we are not using the single bear conductor, but we are using the conductor in standard form. Because the if you are going to use the single conductor, then there is very less there is more chances of breakage. And hence, to increase the flexibility of the conductor, we are going to use the standard conductor. And the standard conductor are mainly in the form of various layers. Means various layers means there is in middle there will be a main conductor, and surrounding that there will be the successive layers of different layers containing, means it may contain 6 wire, 12 wires, 18 wires, or 24 wires. In generalized, we can generalize it with 3n in bracket n plus 1 plus 1, n plus 1 plus 1, means n here n indicates the number of layers. The first conductor is your copper conductor, and it is the properties of conductor. It is mainly we are using hard drawn copper. It is a mechanical process, is drawing how we are molding that copper. But due to the hard drawn copper, the conductivity is going to get reduced slightly, but the tensile strength of the copper conductor is going to increase. And as we know that the current density of copper conductor is very high. As the current density is very high, we will require the smaller cross sectional area. And the smaller cross sectional area means there will be less chances of the surface conductor, means the cross sectional area is small, means there is very less part of the conductor is going to be affected by the wind and other external factors. And also, but there is some um, but the main cause or main disadvantage we can say is the availability of copper in the earth crust is very less. Hence, generally nowadays we are using a aluminum conductor. So the next conductor material is copper aluminum conductor. If we are going to do the comparative analysis of aluminum conductor with a copper conductor, if you are considering this uh, two same conductor having same resistance, then the conductivity of aluminum conductor is 60% less than copper conductor. But the means if it is if the both the conductor means one is your copper conductor and one is your aluminum conductor, if they are having same resistance, then the cross sectional, if we are going to consider the area wise, then the aluminum conductor is 1.6 times having more diameter than copper conductor. Means to carry the same current amount of current in case of copper conductor, you require lesser cross sectional area, and to carry the same current in aluminum conductor you require 1.6 times more area than copper conductor. Second, we can say in comparative analysis, the specific gravity of aluminum conductor is 2.71, which is lower than copper conductor, that is 8.9 gram per cubic centimeter. So we can, by comparing the specific gravity, we can clearly see that the specific gravity of aluminum is less. So as the specific gravity of aluminum is less, we can say that the aluminum is lighter. As it is lighter, we will require less supporting structure of less strength as compared to copper conductor. And as the it is light in weight, it can easily swing up around itself. So we will require the larger cross arms. This is about your aluminum conductor. Next is your steel cord aluminum. In steel cord aluminum means, as we have seen, the copper conductor is having a large having good conductivity, but it is and tensile strength, but it is not largely available, and copper is having less conductivity as compared to copper. And to, if we will mix this two conductor, as we will use the steel cord aluminum conductor. In steel cord aluminum conductor, we in central part we will use the steel conductor, and surrounding that steel conductor we will use the studded conductor of aluminum in layers. So what will happen, it will help us to increase the tensile strength of aluminum conductor. The tensile strength will get increased, and also the conductivity of the conductor will also increase as compared to aluminum conductor. And it is also called as ACSR conductor, that is all conductors steel reinforced. The next and last conductor is your copper conductor. That copper conductor means cadmium conductor, sorry, last conductor is your cadmium conductor. Cadmium copper, this is the last conductor material. In cadmium, it is the means cadmium copper means nothing but it is an alloy of copper. Alloy means we are going to mix the different material in some proportion. In this we are going to add 1 to 2% of cadmium in copper conductor, and due to this addition, what will happen, the tensile strength of the copper is going to get increased by 15%, but but we are going to lose only 50% of its conductivity. It will reduce the conductivity only by 15%. But main disadvantages is that it is only suitable for the cadmium copper conductor is only suitable for smaller cross sectional area, and where the cost of material is comparatively small as compared to the cost of supports. Thank you.